So I said in my last video, if you guys enjoyed the statistical analysis on the 3D printing stuff, I would be doing more of it. Seems like you guys really liked it compared to my other stuff at least, so let's do some more of it. With today's modern generation of 3D printers, like the FlashForge Adventure 5M series that I'm fond of, these Core XY printers are capable of printing at previously unheard of speeds like 600 millimeters a second. And with these ridiculously fast printing speeds, the filament manufacturers are starting to market rapid hyperspeed type filaments specifically for these very fast machines that people are now buying that are commonplace on the market. One of the questions in my head when I started seeing these fast filaments was, does it actually make a difference? And that's the question we're going to attempt to answer today, using the same method of statistical analysis to analyze the capability, the statistical dimensional capability these different filaments are capable of holding with these different print settings. And these print settings are going to be based off of the rapid and hyper type filaments, PLA and PETG specifically, versus the non-rapid hyperfilaments, just the standard marketed stuff, to see if statistically and mathematically do these rapid filaments print better at higher speeds versus the standard filaments of yesterday. So with that, let's take a look at the filaments we're going to be looking at today. The first filament we're going to be looking at is Sunlu PLA Plus in white. Looking at this filament on Amazon today, it looks like they've actually raised their price up to $21 a spool, which is a lot more than I remember it. I remember this being like a $15, $16 filament maybe about a year ago. Looking on my box of filament and the data published here, I didn't actually see anything about a print speed published, but that's okay because this isn't advertised as a rapid or a hyper PLA, just a PLA plus. In my study of the different nozzle diameters, this filament tested the best between this filament and Kingrun PETG for what that's worth, although I have not compared it to any other PLAs. I should say I have not compared it to any PLAs yet, because in this video, next filament up, Elegoo Rapid PLA. This filament is advertised for a max printimum speed of 600 millimeters a second. That is what we're going to be setting our print speed to in order to see if it makes a difference or not. Now this filament's actually coming in a bit cheaper than, quite a bit cheaper than the Sunlu PLA Plus, so keep that in mind. This is priced at what I remember the Sunlu being priced at the time I bought it a while back. So keep that in mind as we're going over the results in this video. So those are our PLA contestants. What about PETG? Next up, we've got Kingrun PETG filament. This is a Chinese brand, bargain brand filament, I would consider it, priced at $13 a spool. Anything you can get for $13 a spool, that's a good price. This filament is being marketed as having a print speed of 80 millimeters a second max and 230 Celsius max. We are going to greatly exceed both of those things in order to match the rapid PETG filament, which is going to be this SaintSmart Rapid Hyperspeed PETG filament. This filament is marketed as having a max print speed of 500 millimeters a second and a max print temperature of 280 Celsius. We're going to set our print speed to 500 millimeters a second and our temperature to 270 Celsius for both of these PETG filaments to see what they do. Looking at the price of this filament, it was $25 a spool, now being sold for almost 50% off at $15 a spool. So keep that in mind as we're trying to review the results for this filament, that it was originally priced at $25 a spool. Alright, let's talk about our printer settings a little bit and how we're going to set up this challenge. So we set up a new filament profile in Orca Slicer, and we changed a couple of things from the standard PETG settings, one of them being this layer time. We turned that min layer time down to 1 second in order to get a fast print time. And we also changed our print speeds to 500 millimeters a second all across the board, except for the first layer. First layer speed settings we left as default. We also changed the max volumetric print speed to 32 millimeters a second, because if we go look at the nozzle specs for the Adventure 5M on Amazon, FlashForge is rating this nozzle for 32 millimeters cubed a second volumetric print speed. Alright, that's great. That's the settings for PETG. What about PLA? Let's take a look. So FlashForge already had a high-speed PLA profile set up in Orca Slicer, but as I recall, it was exactly the same as the default PLA. So the things we had to change were changing our print speeds all up to 600 millimeters a second. And then if we look at the filament itself settings, we did the same things here, where we changed the min layer time down to 1 second, and also changed the volumetric flow to 32 millimeters a second. We did not touch the temperature settings for these PLA filaments. With our filament profile set up, we sliced and diced our models, exported our G-code, set up our automatic G-code for the FlashForge Adventure 5M, so it'll yeet that previous calibration cube and start printing the next one, as you're seeing here. If you're interested in seeing how I set up my printer to do this, what you're seeing right now, I do have a video on my channel about how to set this up so you can clear your print bed and start printing a new print just like that. Go check it out on my channel if you're interested. And just like that, we had 30 white Sunlu PLA Plus printed, 30 Rapid Elegoo PLA Plus, 30 Kingrun PETG, and 30 SandSmart Rapid PETG cubes all printed up. And one big boy printed in Tech Bears PETG with the rapid print settings, because I just wanted to see what it did. Looking at the cubes for the Rapid PLA, they overall look pretty good. The corners were maybe a little bit rounded, more so than on the standard default speeds, but overall print quality looked very acceptable, nothing wrong with that. Next up, we had our Elegoo Rapid PLA Plus. These overall looked really nice and had a nice matte finish to them. Printed really well. I was pretty happy with them when they were coming off the printer. And looking at it just by hand, I kind of thought, you know, that looks pretty good. Maybe it did do better than the white PLA. Hard to tell. And next up were the Kingrun PETG, and I was very surprised by how these looked. I thought they looked very nice in person. I was very surprised by the quality, because it's not supposed to be printed anywhere near as fast as it was, or at the temperature it was. Just looking at the recommended print speeds and temperatures for that filament. So if the Kingrun did well, then the Rapid PETG must have done well, right? Well, these looked horrible. These looked like maybe waterlogged filament to me. Not exactly sure, but this roll of filament was straight out of the packaging and onto the printer. I should not be having water issues with filament right out of the package. To me, not acceptable. Especially when the Kingrun and the Rapid PLA and the regular PLA had been sitting in my room for months. And then I have this big boy in the back from literally a no-name generic Chinese PETG brand that I did not even expect to make it through the print because of the fast and hot print settings, but it did, and it actually looked way better than the Rapid PETG. I mean, look at that. That looks pretty good for just a $10 no-name Chinese brand of film. And again, I just threw this on my printer just to to do it, no reason. And with that, let's get into the meat and potatoes of it. Starting with the Sunlu White PLA Plus at 600 millimeters a second and 220 degrees Celsius. So if you saw my previous video on the nozzle study where I take the different diameter nozzles available for the Adventurer FlashForge 5M and print with the different nozzle sizes and see if there's an effect there, go watch my previous video on my channel if you're interested in seeing that. But what we're going to be doing is what's called a capability study using statistical analysis and a Six Sigma approach. So what I've done is taken 30 measurements in the X, Y, and Z axis on 30 different cubes and done the average, standard deviation, and normal distribution of those curves, which is going to tell me how accurate to itself, how consistent to itself is the filament printing. So if I look at this chart here, what this is telling me is for any number of calibration cubes that I print, typically in a manufacturing context, people say 1,000,000. So let's say, hypothetically, if I were to print 1,000,000 of these calibration cubes, 99.72% of those cubes would fall within this range. This is in metric, not imperial. So again, 99.72% of those cubes will fall within this range, which works out to be just under 3 thousandths of an inch for this filament with these settings in the x-axis of my machine specifically. Then I look at the y-axis of the machine, and it's just over 3 thousandths of an inch. For context, that is thinner than a sheet of paper, which is 4 thousandths of an inch, or just about what the capability in the z-axis was on my machine and this filament, which was amazing to me because when I did my nozzle study with the default settings and this particular filament, it is almost exactly the same capability in the X, Y, and Z axis at the accelerated print speeds versus the default. The only difference between the accelerated speeds and the default settings was the size the cube was actually measuring. So the average at the accelerated speeds was just over 20 millimeters, 20.2 millimeters average, we'll call it. And if I go back to my default settings, the average was right on 20. So the size is looking a little bit larger than nominal. And that's interesting because if I look at the 0.25 nozzle, it was also printing a little bit above nominal with a very similar capabilities. So that's just to say that across these different nozzles and these different speeds, this PLA, Sunlu PLA, is performing very consistently to itself, which means I would say that's a good filament. That is a good performing filament. And the other thing that we can see in the normal distribution charts here is that these are nice curves that are well centered on the mean, which tells me there's nothing that's skewing that data one way or the other. And it's just that's what you expect to see when you're doing this type of statistical analysis. Same in the Y and Z axis. So the surprise to me here was that just seeing that with this increased speed, the filament did just as well as it did with the default settings, which is just about half the speed that we were printing at here. So that's the what I'll say the regular PLA Plus. What about the rapid PLA Plus? Well, if I go over here and look at the capability, you're just over 3,000ths of an inch in the X, just over 3,000ths of an inch in the Y, and just over 4.5 thousandths of an inch in the Z. Comparing that to the Sunlu PLA, it actually looks just a tiny bit worse than the Sunlu PLA. Now, practically speaking, twice nothing is still nothing. These are basically equivalent to each other just looking at these numbers. They're very similar, and again, 4,000ths of an inch is the thickness of a sheet of paper, and if I were to print a million of these cubes in these two different filaments, 99.72% of the time these filaments are going to be within these ranges of each other. Now, the one thing I noticed about the rapid PLA that looked better than the standard PLA, with the rapid PLA, it held closer to the nominals than the standard PLA. The rapid PLA held the nominals a little tighter than the rapid. Here's the thing though, you can do things in your slicer like scale the print to compensate for that kind of thing. So given that the capabilities were so close, if and the rapid was a little bit closer to nominal, I have a hard time picking a winner between these two, and I would say they're really more or less equivalent. Now keep in mind, looking at the prices on Amazon, Sunlu White PLA was $6 more per roll than the Elegoo Black Rapid PLA. So you're getting basically equivalent performance for a better price with the Rapid. But what about the PETG? Let's take a look at the PETG. Starting with the Kingrun. Now, this absolutely blew me away when I saw the numbers. Looking at the capability of the Kingrun PLA, 2.5 thou in the X, just under 3 thou in the Y, 4,000ths in the Z, which is just about the same as the default settings for the Sunlu PLA Plus with a 0.4 nozzle. And if I look at the Kingrun PETG default settings with the 0.4 nozzle, just over 4,000ths in the X, almost 8,000ths in the Y, and 16.5 thousandths in the Z, that was just an artifact of my automatic printing. Watch my nozzle study video to understand that. The Z should not be that bad. That's just an artifact of the automatic printing for that particular study. But the X and Y I would consider legitimate. This Kingrun PETG filament crushed it with the higher print speeds and temperatures. And again, these print speeds and temperatures vastly exceed what's recommended for this filament. And in fact, looking at how close the capability of this filament is to the PLA filament, well, the Sunlu PLA filament, I'm kind of thinking that these are more of artifact of the actual printer capability rather than the filament. So that's to say that it seems like we're reaching the capability of the printer itself, not the filament. So, and I think that's why these numbers are so close to each other, because now you're getting down to the level of accuracy the machine itself is capable of doing, not the filaments. So it's possible that if I got a more accurate and precise 3D printer, these numbers could actually come down even further. And keep in mind, this is a $13 just regular run-of-the-mill PETG filament. That blows my mind how well this did. And what also blows my mind is how poorly the PETG from SandSmart did. Just looking at the surface texture of those prints, they looked like waterlogged filament to me, which was very disappointing because I opened that filament and immediately put it on the printer and ran these samples, which means it came from the factory, probably waterlogged. If it's not waterlogged and the filament's just that bad, whew, that's really rough. Any way you cut it, this filament, if they were trying to sell it for $25 a spool, no wonder it's going on sale for 50% off, and they're just trying to get rid of it because this stuff is junk. I mean, you're talking 8 thousandths in the X, Y, and 6 thousandths in the Z, doing just much worse than the Kingrun PETG and the even the default. I mean, ignoring that, your Y's are similar, but your X is half, just about half of that. So the Kingrun is just way better than that. So at the end of the day, looking at how the Sunlu PLA Plus compares to the Elegoo Rapid PLA Plus, not much difference there. If anything, you know, the same. Go with the Elegoo in that case because it's a little bit cheaper, not because it's a rapid filament. And then look at the Kingrun versus the SandSmart. The Kingrun just blows it out of the water, no contest, even at the rapid PETG settings. I was very surprised when I saw those numbers, how well that did. So one other thing I wanted to show here before I ended this video, the print time for the PETG, about 10 minutes per cube. And then if I go back to the default settings for PETG and do setting over cooling, I think this was like 6, or no, I don't have to play with those. I can go back to just PETG. Go back to these settings, 8 seconds, and where's the flow? 12 millimeters cubed a second for the PETG, and those are all the same. Slice that. I'm cutting off 6 minutes of print time with the PETG per cube. And then with the PLA, go back here, 600, 600, 600, 600, 600, 610. Slice. The same, about 10 minutes for the cube in the rapid PLA settings. And then if I go back to the default PLA, I'm at about 13 and a half. So significant amount of time I'm cutting off of these prints and getting that kind of performance. So anyway guys, I hope you enjoyed this video. Give it a like, thumbs up, subscribe for more content like this in the future. Again, this is 3dprintedmolds.com. Thanks for watching. Hope to see you next time.